Right now, as you're listening to these words, around 8 billion people are breathing together under one atmosphere beneath the same sky. But in the vastness of outer space, are we truly unique? For more than 60 years, humanity has patiently sent countless signals into the cosmos. We've listened to every frequency, scanned every patch of darkness, waiting with the hope that someday, somewhere, someone might respond. Yet, all we've received in return is a vast expanse of silence, a silence so profound it's almost unsettling. This forces us to ask, in a universe with over 2 trillion galaxies, each holding hundreds of billions of stars, could it really be that intelligent life has blossomed only on one small planet called Earth? According to some scientific estimates, there could be as many as 36 advanced civilizations coexisting with us right now in the Milky Way alone. Our closest neighbor? Possibly just 17,000 light years away, a distance both cosmically near, yet despairingly far. So why, after all this time, have we still not encountered anyone? Why does the universe seem drowned in silence? In today's video, we'll explore the latest research from Oxford and Nottingham, unravel the legendary Drake equation, and confront a possibility that sends chills down the spine. Are we truly alone in this universe? The answer, if it exists, could forever change the way we see ourselves. To understand why the question of humanity's loneliness matters so much, we must first confront an overwhelming truth: the immense scale of the universe. Let's begin with our home, the Milky Way, a spiral galaxy that may seem ordinary, no different from the billions of others spinning in endless space. And yet, this single home is staggering on its own. 400 billion stars. 400 billion. If you were to patiently count one star every second, it would take more than 12,000 years to finish. And that's just the starting figure. Recent studies suggest that the vast majority of these stars, perhaps up to 90%, host at least one planet in orbit, which means that within the Milky Way alone, we may be looking at hundreds of billions of planets. But the true shock doesn't end there. The observable universe contains up to 2 trillion galaxies, and each of those galaxies holds hundreds of billions of stars. Picture this. If every grain of sand on all the beaches of Earth represented a star, the total number of stars in the universe would outnumber those grains of sand by 10,000 times. With numbers so immense, the idea that Earth alone nurtures life seems almost impossible to believe. That's why scientists continue to ask, can we estimate the likelihood of life elsewhere in the universe? And it is precisely this question that gave rise to a famous equation, forever linked to the name of astronomer Frank Drake. In 1961, at a scientific conference in West Virginia, astronomer Frank Drake faced what seemed like an impossible challenge. How could we calculate the number of intelligent civilizations that might exist in the Milky Way? From that very question, one of the most famous equations in science was born. The Drake equation looks like this: n equals r star times fp times ne times fl times fi times fc times l. Sounds complicated? In truth, it isn't. The genius idea was to break a massive question into 7 smaller factors we could attempt to estimate. R star, the rate of new star formation in the Milky Way each year. Current estimates suggest about 1 to 3 new stars are born annually. This is one of the easier numbers to measure. Fp, the fraction of stars with planets. Thanks to the Kepler telescope and recent studies, we now know this number is as high as 90%. Nearly every star has at least one planet. Ne, the average number of planets per star that fall within the habitable zone. Not too hot like Mercury, not too cold like Uranus, just the right distance for liquid water. Estimates suggest around 0.1 to 0.2 habitable planets per system. But from here, things get mysterious. Fl, the probability that life actually appears on a habitable planet. This is something we have no idea about. It could be 100%. Life arises naturally everywhere. Or it could be 1 in a trillion, a miracle that happens almost never. Fi, The probability that simple life evolves into intelligence. On Earth, life began 3.8 billion years ago, but intelligence emerged only 200,000 years ago. Is that normal, or are we the exception? FC, the fraction of intelligent civilizations that develop communication technology. Not every intelligent species may invent radios or the internet. Perhaps they communicate in ways we can't even imagine. L, the average lifespan of a civilization capable of communication. This is the most chilling factor. Humanity has had radio for just 120 years. Will we last another 100 years? 1,000 years? Or 1,000,000? And that's the haunting part of the Drake equation. The first three factors can be measured with some accuracy. The last four, pure guesswork. With optimistic estimates, the result could be thousands of civilizations in the Milky Way. With pessimistic ones, the answer might be just us. That's why, when a research team from the University of Nottingham proposed an entirely new approach, the scientific world took notice. In 2020, while the world was in the grip of a pandemic and isolation, a research team at the University of Nottingham published a discovery that shook the scientific community. They claim to have calculated a specific number: 36 intelligent civilizations currently coexisting with us in the Milky Way. 36. Not too many, not too few. Just enough to suggest we're not completely alone, yet few enough to explain why we've never encountered anyone. Unlike the speculative guesses of the Drake equation, the team led by Professor Tom Westby and Christopher Consolis based their approach on a principle that was both simple and brilliant: the Copernican principle in astronomy. The core idea is straightforward. If Earth is not the center of the universe, if there's nothing inherently special about us, then the formation and evolution of life here are not unique. In other words, what happened on Earth could just as well happen elsewhere under similar conditions. From this, they established a strict set of criteria called the astrobiological Copernican limits. First, the star must be a G-type like our Sun, or a K-type, smaller and more stable. It must have a minimum lifespan of 5 billion years, long enough for simple life to evolve into intelligence as it did on Earth. Second, the star must be metal-rich, containing heavy elements like iron, silicon, and carbon, the building blocks for rocky planets and technological foundations. Finally, the planet must orbit within the habitable zone, where liquid water can exist. When these conditions were applied across the Milky Way, the results stunned many. 97% of stars had already surpassed the 5 billion year threshold, and roughly 1/3 of those remained stable long enough to sustain planetary systems. After excluding stars that were too hot, too cold, unstable, or metal poor, the final figure they announced was 36 civilizations. Of course, that number is not absolute. Depending on assumptions about the pace of evolution or the lifespan of a civilization, the figure could range anywhere from 4 to 211. Still, 36 stood out as the most reasonable estimate in their model. Intriguingly, the nearest civilization might be just 17,000 light-years away, a vast distance. Yes, but by cosmic standards, practically next door. Even so, if they were to send a radio signal today, humanity wouldn't receive it until the year 19,024. As captivating as the idea was, not everyone agreed with the number 36. And it was precisely those criticisms that opened the door to an even more unsettling question. Seth Shostak, senior astronomer at the SETI Institute, who has dedicated his entire career to searching for extraterrestrial intelligence, quickly issued a strong rebuttal to the Nottingham study. The calculations that led to the number 36 civilizations, Shostak emphasized, are really just arbitrary estimates. Using the same approach, you could come up with any number you want. And he wasn't exaggerating. The core problem with the Nottingham research and with the Drake equation itself is that both rely on one colossal assumption, that Earth is ordinary. But is it really? Just look at our planet's history. Earth has gone through not one, but 5 mass extinctions. The most recent, 66 million years ago, when a giant asteroid wiped out the dinosaurs and 75% of all life, and that very catastrophe cleared the path for humanity. Without that impact, perhaps today the rulers of the planet would be intelligent dinosaurs, not us. But our luck doesn't stop there. Earth has a massive moon that stabilizes its tilt and creates tides, conditions crucial for nurturing early life. We have Jupiter, a giant shield pulling in dangerous asteroids. We have a strong magnetic field, a protective ozone layer, and a molten core that has sustained geological activity for billions of years. Are all these cosmic blessings really common? Oxford philosopher Nick Bostrom introduced a chilling concept known as the Great Filter. It suggests that most life inevitably runs into an evolutionary barrier that is nearly impossible to overcome. Maybe it's the leap from non-living matter to life. Maybe it's the jump from single-celled to multicellular organisms. Or maybe it's a step humanity has yet to face. If the Great Filter lies ahead of us, then most civilizations will self-destruct before they ever reach the stars, through nuclear war, climate collapse, runaway artificial intelligence, or some catastrophe we can't even imagine. That would mean our failure to detect anyone else may be a warning, not good news. But there's another possibility, equally chilling. Other civilizations might already know about us. They could be watching in silence, and they remain silent for a reason. Author Lou Sixon calls this the dark forest. The universe is like a cosmic night forest, where every civilization is a hunter with a gun. Whoever makes a sound is shot. In a universe where resources are finite, the safest survival strategy may be to eliminate every possible threat. And if this theory is right, then humanity's 120 years of radio broadcasts into space could very well be the greatest mistake in our history. All lines of reasoning eventually lead to a famous paradox tied to physicist Enrico Fermi. In 1950, during a casual conversation at Los Alamos, he asked a question that seems simple, but remains haunting to this day. Where is everybody? That is the essence of the Fermi paradox. If the universe is vast, with hundreds of billions of stars, if life can arise on countless planets, if even a tiny fraction of them evolve into technological civilizations, then why haven't we seen anyone? No radio signals, no exploratory spacecraft, no colossal artificial structures like Dyson spheres built around stars to harvest their energy. This absolute silence, it's truly terrifying. Imagine, if a civilization were just 1,000 years ahead of us, a mere blink in cosmic history, they would wield technology beyond our comprehension, the way medieval people could never imagine the internet or spaceflight. And if they were 10,000 years ahead, 100,000 years, a million, they would seem like gods to humanity. With such power, colonizing the galaxy would only be a matter of time, and yet we see nothing. So what are the possible explanations for this silence? Hypothesis 1. We are truly alone. Intelligent life may be so rare that it has only ever appeared once, here on Earth. Hypothesis 2. They exist, but they're too far away. Even 17,000 light-years is an unbridgeable gulf with our current technology. Hypothesis 3. They have disappeared. The universe may once have echoed with voices, but most civilizations self-destruct, leaving behind a galactic graveyard. Hypothesis 4. They are hiding. The universe may be dangerous, and silence is a survival strategy. Hypothesis 5. They don't care. To them, humanity might be no more significant than ants, alive, but unworthy of notice. Hypothesis 6. We are an experiment. Perhaps Earth is nothing more than a cosmic zoo, observed quietly from afar. Whichever hypothesis is true, the silence of the universe is sending us a message. It may be a warning, evidence of the extreme rarity of intelligence, or a hint at unforgiving laws of survival we have yet to uncover. And it is precisely this silence that opens the door to the final question. After all the numbers, the chilling hypotheses, and the paradoxes without answers, we return to the original question: is humanity truly alone in this universe? And the wonder is this: despite the unsettling silence, despite the debates among scientists, most of us still believe that the answer is no. Why is that? Because the universe is simply too vast for only one planet to harbor life. Remember, 2 trillion galaxies, each holding hundreds of billions of stars. Even if the odds of intelligent life arising were just 1 in a trillion, we would still be talking about millions of possibilities. And we have already begun to find clues. The James Webb Space Telescope has detected water vapor, carbon dioxide, and organic molecules in the atmospheres of exoplanets. Perseverance is searching for traces of ancient microbes on Mars. The Europa Clipper is set to dive into the hidden ocean beneath the icy crust of Europa, Jupiter's moon. If there were a logbook of planets that host simple life, the list would surely be staggering. And if primitive life is common, then the emergence of intelligence, in at least some cases, is only a matter of time. But perhaps we are searching the wrong way. Perhaps advanced civilizations no longer use radio waves. Perhaps they communicate through quantum entanglement, gravitational waves, or dimensions we cannot yet grasp. Perhaps they have digitized consciousness, living in perfect virtual universes, no longer concerned with the physical world. Or they might be so advanced that they need no colossal Dyson spheres for us to notice. Or they are simply waiting for humanity to mature, to learn how not to destroy itself, and to be ready to join a greater galactic community. The hopeful part is this: we, this very generation, are the first to have the technology to search for answers seriously. Space telescopes, modern SETI projects, atmospheric analysis of exoplanets, all are now within our reach. In the next 10 to 20 years, we may know whether simple life exists within our solar system. In 50 to 100 years, we could have an entire library of biosignatures from hundreds of distant worlds. And if we find even a single bacterium beyond Earth, we will know that life is not unique. And if life is not unique, then intelligence cannot be unique either. That moment will reshape philosophy, religion, science, and the very way we see ourselves. It will show us that humanity is not the center of the universe, but a small part of something infinitely greater. And perhaps right now, 17,000 light-years away, an intelligent being is looking up at its sky and wondering, are we alone in this universe? The answer, most likely, is no. If you enjoyed this video, don't forget to hit like and subscribe to support the channel and help us create more content about science and the universe. Every subscription gives me more motivation to research and bring you even more fascinating scientific stories. And don't forget to ring the notification bell so you won't miss the next videos.